Okay, today we're gonna complete the square, and usually this technique is used for solving quadratic equations or trying to get certain equations like the standard form of a parabola. So complete the square. If you notice the title, this word complete means or implies that the square that you have is incomplete. So here's the problem that I'm proposing. It's x squared plus 6x plus blank. Now this is the piece that is missing in order to complete the square, and that's our job. Our job is to complete the square. And so x squared I'm going to represent with this blue square right here, and 6x's is this these four green rectangles right here. And the reason why we're labeling this as x squared is we don't know the length of the square. So if you look at the area of the square, it's x squared because x times x is x squared. Notice the length of the green rectangle is also x. So that implies that it's x by 1 unit right here. X by 1 unit. And so x times 1 is of course x. So each of these green units here represent an x. And so you're going to try to rearrange these green little rectangles and the square included, all of these guys. Ignore this little section over here. We're going to look at this x squared plus 6x, and we're going to try to arrange these little guys so that it makes a square. Let me leave some space there so it makes more sense. And notice if I keep just adding pieces here, we're never going to get to a square, because a square is defined as, let me jog your memory really quick. What is a square defined as? It is defined as having 4 congruent sides, or 4 sides that have the same exact length. And then of course it also has the right angle right here. So this is a square right here, this blue area, because this length and this length are exactly the same. And also these angles right here are right angles, or 90 degrees. And so notice if I just keep adding x's this way, like I did, I'm never going to make a square. So I need to think, like, how can I rearrange this that it could be a square? Now let me put some down here. Let me see if that's the trick. And of course, that's not the trick. But if I could take them and rotate them like that, right? I get a more square-like figure, right? Let me rotate this guy, put him here. And the last one. So I know you're probably thinking, okay, is that really a square? And no, it's not. It's missing it. That's why we have to complete the square, right? So we're going to try to complete the square. And over here we have the problem. Over here, this is what the answer is going to look like. So we have something in here that is being squared. So complete the square means, number one, it's a physical object and we're trying to make a square. We're going to put some stuff here. And number two, the answer is going to look like a squared, because something squared represents a square, because length times width. Okay, and so I'm thinking about how many units I need here to make it. And these little yellow squares represents 1 unit, because it's a 1 by 1. And if I arrange these, I'll kind of get a perfect square. And your job is to figure out, before I drag all these over here, how many of these am I going to actually need? And then your job as a mathematician is, how can I streamline this process and not have to draw these squares out every single time, because that might be cumbersome. All right, so hopefully you've counted how many I needed before I am done with all of these little yellow guys. Ooh, that went crazy there. And so if you notice, now I have a square-like looking figure. And in math we can't assume anything, so let's just make sure that we know. So the length of this side right here is x. And these little lengths right here, 1, 1, and 1, makes x plus 3. The length of this side is x plus 1, 2, 3. The length of this side is x plus 1, 2, 3. And the length of this side is x plus 1, 2, and 3. So as you can see, this is a square, and I'm just going to say that these are right angles because they were rectangles and squares before, so therefore they're still right angles. And so the number that's missing in here, right here, is going to be a 3. And we should know that because there's 1, 2, 3 units here. Now, so our job is to figure out how did we get from here to here. Now, we did it with pictures. Let's see if we can do it with some numbers. Okay, so let's start with this problem right here. Let's move them. Oh, I can't move them. All right, so let's start with this problem right here, x squared plus 6x. What did we do first? Well, we took this box, right, this square, and we put it here. And then what did we do to the 6x's? We lined them all up here, but we didn't get a square. So what I did is I broke it up into 2 nice pieces, into even pieces. So that means that I'm going to take the 6 and divide by 2. So number 1, I'm going to take 6 and divide it by 2, right, which is 3. And you could notice that 3 happens right there, which totally makes sense because that's the side. That's the extra little piece aside from the x. Oops, I don't know what I'm doing. Hold on. Okay, and then what did we do to that 3 to get this set of pieces right here? How did we do that? Well, you notice that we did 3 times 3 because that's a little square in there. So then we take 3 and then we square it, which gave us 9. So there's what the answer looks like. But here's the piece that was missing, the 9. So that 9, of course, comes from over here. And then that and that are the same exact thing. So x squared plus 6x plus 9 could also be rewritten as x plus 3 quantity squared. So that quantity just means parentheses. So why don't you try a problem? Let's see if I can come up with a problem on the fly here. Let's write it as x. Here, let me ignore that. Just ignore what I just wrote for you. Let me erase that. Put it in a different color so that it stands out more. Here, you try this problem. So let's try x squared plus 12x plus blank. And then that will equal to x and then something and then squared. So you try this problem, draw it out with little square-like pieces like this, or try the math right here. I'm kind of against the whole idea of teaching you a formula just because the formulas don't really stick, and so these pictures give us a meaning. So that's why I'm showing you these pictures. So hopefully you can imagine this x squared and what he looks like. And he's an x squared, right? And then the 12x's, what they would look like, these green little sticks right here. And then how would you break that up so it actually makes a square? Important. What number is going to go here? So this is task number 1. What number is going to go right here? And then number 2, what are you going to fill in this space right here? Is it going to be plus something? And if so, what is it? So there's the task that I have for you. You try it and let me know how it goes. Hope you learned something and enjoy.